Have you ever just stopped everything to look up at the sky during an eclipse? It's just one of those incredible moments that kind of connects all of us, doesn't it? Well, today, we're going to pull back the curtain on these amazing celestial shows. We're going to get into exactly how and why they happen. So, let's dive into the cosmic mechanics behind these absolutely breathtaking events.
It seems like a simple question, right? But the answer is pretty profound. What is actually going on when the daylight just fades away, or the full moon turns that eerie, spooky red? It's all part of this incredible cosmic dance of light and shadow, and you know what? We're gonna break it all down.
Okay, so first things first, let's get a handle on the basic idea of what an eclipse even is. Before we jump into all the different types and, why they're so incredibly rare, we've got to start with the basics.
And it's really that simple and kind of beautiful, right? It's not magic, it's geometry. An eclipse is just one object in space casting a shadow on another. And for us, the main players in our little cosmic neighborhood are, of course, the sun, the earth, and the moon.
Yeah, you can think of it like a recipe. You need 3 key ingredients to get it just right. Step 1, you need a light source. That's our sun. Step 2, you need something to block that light. That's going to be either our moon or the earth. And step 3, the most important part, everything has to line up perfectly to cast a shadow. And that shadow, that's the eclipse.
All right, so we've got the basic recipe down. Now let's talk about the 2 main dishes on the menu, solar and lunar eclipses. They both use those same ingredients, light and shadow. But the real difference? Well, it all comes down to who's doing the blocking.
Okay, this lays it out perfectly. For a solar eclipse, you've got the sun, then the moon, then the earth. See? The moon's tiny shadow is what falls on us. But for a lunar eclipse, the order gets switched up. It's sun, earth, then moon. So our planet's giant shadow is what covers the moon. It's pretty cool, right? One darkens our day, the other messes with our night.
And get this, solar eclipses aren't all the same. You've got a few different flavors. Of course, there's the big one, the total eclipse, where the sun is completely gone. Wow. Then you've got a partial one, where it looks like a bite's been taken out of the sun. But maybe the coolest one is the annular eclipse. That's when you get that spectacular ring of fire. But okay, super important safety warning here. I'm not kidding. Never ever look directly at the sun during any of these. You need special, certified glasses. Seriously, don't risk.
Okay, now let's flip over to the other side, the lunar eclipse. Now this is a totally different vibe. It's way more chill. You can just sit back and watch it with your own eyes, no problem. It's completely safe. And they can last for hours, so you've got plenty of time to just take it all in. And if you're lucky, you get that amazing blood moon effect.
So why does it turn red? What's going on there? It's actually this beautiful little trick of the light. Imagine all the sunlight that's just skimming past the edges of the Earth. As it goes through our atmosphere, all the blue light gets scattered away. That's why our sky is blue. But the red light, it punches right through, gets bent a little, and shines right onto the moon. It's like all the sunrises and sunsets happening on Earth are being projected onto the moon's face at once. How amazing is that?
All right, so this is where it gets really interesting. The moon goes around the Earth every month, right? And we go around the sun every year. So that leads to a really obvious question. And the answer is the secret to why these events are so special.
Yeah, why don't we get eclipses every single month? It makes sense, doesn't it? If the moon's making a lap around us every 4 weeks, shouldn't it line up perfectly every single time? Well, as it turns out, the universe has a little wobble in its plan.
And here it is, the big secret. The moon's orbit is tilted. It's not perfectly flat. It's tilted by about 5 degrees compared to Earth's orbit around the sun. So most of the time, when the moon passes by, its shadow just misses us. It goes either too high or too low. Eclipses can only happen during those couple of short windows each year when the tilted paths cross at just the right moment. And that's what makes them so rare.
So yeah, they're rare, they're beautiful, but eclipses are so much more than just a pretty sight. They're actually like a natural laboratory that lets us study our universe in some really incredible ways.
For centuries, scientists have used eclipses to make some absolutely groundbreaking discoveries. They give us a chance to study the sun's outer atmosphere, the corona, which is usually totally invisible. But here's a huge one. Back in 1919, a total solar eclipse helped prove Einstein's theory of general relativity. For real! Scientists saw that the sun's massive gravity was literally bending the light from distant stars, just like he predicted. That's a huge deal. They also help us learn about our own atmosphere and just generally understand the clockwork of space.
And that's really the ultimate takeaway here. The fact that we can predict these things down to the second, hundreds of years from now.
That's just an incredible testament to how well we understand our solar system. These celestial shadows are this amazing reminder that we live in a universe that's just full of breathtaking order and, well, wonder. So the next time an eclipse is coming, you'll know exactly what you're seeing. It's not just the sky getting dark. It's that cosmic dance of light and shadow playing out right above your head.